Hello statistics student, this video is for chapters 3.1 and 3.2, probability. So the probability that we talked about will gear towards understanding statistics sampling and also how it applies to statistics. But we still have some terms that we need to get used to in probability. 3 terms: sample space, event, and P open parenthesis A. Sample space in probability means the total possible outcome of a procedure. Sometimes a procedure is an experiment. Sometimes the procedure is doing some selection and then looking at the outcome. So these outcomes are all by chance and equally possible. So in a sample space, all the outcomes should be equally possible. Event is the result of a procedure, so it's the outcome. So we use capital letter to symbolize an outcome, an event. So we call it A, B, or C capital. And if I want to describe the chance of a outcome, probability of A, something A has not happened, I'm to do a procedures, I want to look at how likely or what is the chance of a particular outcome to happen. We write P open parenthesis A, probability of event A occurring. There are possible values of A, so you use mathematics to represent this instead of objectives saying that, oh, this is likely to happen or it is certain to happen. So what happens is we have, if it is very likely, it is certain to happen, we say P of A equal to 1. It looks like a function notation, but it is just a short form of probability of A. So it is not multiplication, it is not a function. So probability of A equal to 0 means A is impossible. So any things in between 0 and 1 would be a probability of an outcome. And we'll discuss why this has to be between 0 and 1 and not greater than 1. So the probability is the event is less than 0.05. We say that this event is unlikely. It's very rare, and we call it a rare event. A is a rare event. If it happened, we're very surprised. So in realities, no matter how unlikely an event is, it will happen. But for statistician, we say if we see something that is unlikely to happen, we would use it to draw some conclusion. So an event, if it has such a low chance but has happened, then we will draw conclusion. What about if something is 50-50? 50-50 chance means it has equal chance of happening as well as not happening. So a probability of A is 0.5. Some example of A that is 50-50 would be if you toss a fair coin. So it could be 50% head, 50% tail. If you look at the outcome of a baby birth, so a baby is being born, whether it is a boy or girl, it's also 50-50. So far we know that the gender is 50-50 chance. What happens is also some example would be multiple choice question. So if someone guesses a multiple choice question, and so let me see some example. Example of 50-50 is toss coin. Probability of head and or tail. Head is 0.5. Birth of a girl. So birth probability of a girl is also 0.5. And so this is the second one. The third one that usually shows up in probability question would be you guess a true-false question, and you are to do random guessing. So if you know it, of course, you would be certain to get it right. So the probability that you get it correct, is 0.5 if you're guessing. Okay. So other than that, how can I find probability of an event? Okay. So for example, I select a card from a standard deck. How do I know what's my chance of selecting a red card or a red heart card, right? So these are the different way of approach to find probability of an event. So the first is theoretical or classical approach. The second is relative frequency approach. And the third is just subjective estimation. So of course 1 and 2 are the most standard one. And then approach 1 is more mathematical, and approach 2 is where statisticians use. That means you collect data and you use the data to represent the probability. So the first is called classical approach, is you analyze the number of ways in the sample space. So you count the number of ways in the sample space, and then you, out of all the possible outcome, you count how many is that A occurs. So in this sense, this is very important to find probability of A. You look at what is favorable to A over the total possible. Again, the total possible way has to be equally likely. For example, you select one card from a standard deck. So this would be, you would look at the sample space as in the standard deck. There's 52 cards, right? So so I have 52, and then there you want to have a card of hearts. Heart is what? That's 13 heart card in the standard deck, because you would have 1 to 8. 1 is A, right? To 10, and then Jack, Queen, King. So it's 13. So 13 of them over 52. So you count all those are favorable to you versus the 52 that is possible. So it is 1/4 after you simplify, and it's 0.25. You can write 25%. In this class, our standard is to write in decimal. Okay, you can write in fraction too, but we usually write in decimal. Percent is when you're writing a sentence. Okay. The second example is you have a batch of shipment. It's 6,500 light bulbs, and 80 of them are defective. You know about it because of the manufacturing process. You can guess that they are defective. And now you're going to select one light bulb from the batch. So what is the possibility of defective? So the sample space is the 6,500 light bulbs, and then 80s are the one that fits your defective requirement. So we'll do 80 over 6,500. Round to 3 or 4 decimal places. In this case, we round to 3 significant figure or 4 places. It's like that. What is the probability that you select one? Look carefully. You select one. You're not selecting all 80 or whatever. You select one. Probability of that one is good is, how many are good? Okay, so 6,500 minus 80 are the one that fit the description of good. And you divide it by the total, so that would be 0.988. Okay. Number 3, example 3 would be a family have 3 children. So what is the probability that that 3 children family has 2 boys? So you might say, well, the sample space may be 0 boys, 1 boy, 2 boys, 3 boys, right? You might be thinking that, oh, it is they have 2 boys, so it's 1/4. But it's actually not. It's 3/8. Why? Because the sample space, because these are not equally likely. So to have 3 children, you could have boy, 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 like these are the order of the birth. The order of the birth is 50-50. So you can have boy, 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 girl, boy, girl, boy. These are all the options of having 3 children in the orders of 3, like sequence of 3. So it turns out that how many fit 2 boys? So this would be exactly 2 boys. This is exactly 2 boys. This is not. This one is exactly 2 boys. So it's 3 cases, 3 counts out of 8 counts. So it's 3 over x, 0.375 if we want decimal. So these are analyzing the number of possible outcome versus your outcome. So this is a simple one, so it's very easy to analyze. Sometimes it is not possible to write these all possible equally likely events in the sample space. So we'll use something called relative frequency approximation. In chapter 1 and 2, you have come across what is called relative frequency. Relative frequency is you're counting something that matches what you want to count, a category or a particular class, over the total, right? Over the total. So it's the same idea. You would do a procedures, you repeat it a lot of times, and then you count the number of times that A occurred, the one that you want. So and you use it to estimate what is going to happen next. Okay, so this would involve sampling. So for example, the first example, you sample 568 students. Out of those, 320 students are full-time students. And if you are to select one from the whole populations of students, you see how they did not have the whole population of students. They do not count how many are full-time, so they use a sample and they use it to estimate. So out of the 568, you have 320 that are full-time. So if you do the relative frequency of full-time, that would be 320 over the total. It's 0.563 or 56.3%. So these are from the sample because you repeatedly select 500 students in the population, and then you use this to predict out of the whole population, 56.3% are full-time students. Now, this is only valid if the sample is representative, right? If the sample is not a good sample, it is you only select people at nighttime student, or you only select in one parking lot, it is not representative, then this is not correct. So it has to match your population. It has to be representative of the population. So there's a question like that in the classwork. The second one is about, seeds and growing. So you have a batch of flower seeds and you want to grow flowers, but because of genetics, so sometimes the plant develops white flowers, some develop pink flowers. So there are 78 white and 65 pink flowers. So if I am to plant another plant, would I get a white? What is the chance of getting a white flower? So you would say the white flower count would be 78 and it's over the total. So it is over 65 plus 78. So this is the total. Okay, it's kind of like you do a relative frequency. You always add the total. The first one, you don't have to add any total because this is the total already, right? This is the total. So in some case you have to add, in some case you don't. So 78 over whatever that you add together, that's 545. So that's 54% chance of getting a white flower when you plant it the next time. So there is another one that we would do in class. It is a Monty Hall game. The Monty Hall games is like this. If you have 3 doors behind the 3 doors, one of them would have a prize. One of them behind them, it would be a prize. So the contestant or the player would select one of the doors, open it, and you would see, oh, I selected right, it's the prize. The other one is like a goat or not something that is useful. So no prize. In the other two, one of them has a prize, but you don't know what. So what is the chance of winning? The chance of winning would be 1 over 3, right? But the game is adjusted in such a way that after you pick your door, and they don't open the door for you to check first, they will open one door that has no prize. So for example, you pick this, and then the host would say, okay, you pick this because it's the host, right? They know which one has no prize. So for example, he or she would know that this one has no prize. He or she would open this, open for you to see that, oh, there's no prize, none. And now you have a choice of keeping your own pick or switch to the new one. So what is a better strategy? Should you always switch or should you keep the old one? So this is very difficult to calculate in terms of the total number of possible events and all those. But you can do this by doing the procedure multiple times to see which one is better. So you can actually go online. There is a simple Monty Hall game. If you Google Monty Hall games, you can see this one under interactive, I think, and then you would play it and you will see which one is better. Okay, so this is called relative frequency procedures, and it's based on law of large number. If you don't know a probability of something, you repeat it so many times, it will become the real probability.